Magandang araw po sa inyong lahat. Ako po si Jonathan F. Secretario, and I am about to discuss autotransformers, comparison of transformer, and autotransformer. Before tayo mag-start sa main topic, let's have a brief discussion about the definition of an autotransformer. So sabi dito, ang autotransformer is a special type of transformer na mayroong single continuous winding with the same purpose of raising and lowering the voltage katulad ng isang ordinary transformer. Pero, nagkakaroon daw ito ng konting pagkakaiba sa kanilang application. As you can see in the figure, meron lang talaga siyang isang winding, but parts of this winding are considered as the primary and the secondary. The winding AC forms the primary, and yung portion ng winding na ipinapakita as the BC forms the secondary winding, and that is what you call an autotransformer. So let's proceed to the next slide. Proceeding to the main topic. So I have here a list of the differences between the autotransformer and the conventional transformer. So the definition, I have already discussed this in the previous slide, na ang autotransformer is a type of transformer na meron lamang isang winding na kung saan merong parts na nag-act as a primary and a secondary. Sa transformer naman, this is a static machine na kung saan nga nagtatransfer siya ng electrical energy from one end to another without changing frequency. Hindi na kailangang i-elaborate. Number of windings, hindi na rin kailangang i-elaborate. Ang autotransformer has only one winding and the conventional transformer has two separate windings. The symbol shows the obvious. Yan na nga. Ang autotransformer has only one winding na kung saan hinati ito sa dalawa na nag-act as the primary and the secondary, while dun sa conventional transformer, there are two windings which are separated. So yun po. Next slide. In terms of insulation naman, so dahil nga ang autotransformer has only one winding, yung primary and secondary winding nito are not electrically insulated. And dun sa conventional transformer, the primary and the secondary winding are electrically insulated from each other because yun nga, yung dalawang winding are separated, which means the primary and the secondary are actually separated from each other. In terms of induction, the type of induction that the autotransformer uses is the self-induction. It induces the electromagnetic force doon sa circuit gawa sa variation sa current. While doon naman sa ng conventional transformer, which we already know, the mutual induction. In terms of size naman, the autotransformer is smaller in size compared to the conventional transformer. Maybe dahil gawa nga doon sa part na iisa lang na winding ang ginagamit ng autotransformer. About sa ng power transfer, it is said here na partly by transformation and partly by direct electrical connection. While itong naman sa conventional transformer, it is purely through transformation process. Next, in terms of voltage regulation, sabi ang autotransformer daw is much better kaysa sa ng conventional transformer. Gawa ata kasi ito na ang pinaka definition ng voltage regulation daw is yung change ng secondary voltage from no load to full load. So nagkakaroon ng mas better ng voltage regulation do sa autotransformer. While sa naman ng winding material, dahil nga one winding lang siya, it has less requirement yung ng autotransformer. While dito sa kabila, it has more requirements dahil nga two windings ang kailangan dun sa construction ng transformer. So next slide po. So next, in terms of circuit naman, base dito sa ng table, dun sa source na pinagkunan ko, ang auto transformer daw ay yung connected magnetically, while the conventional transformer is yung primary and secondary winding circuits are connected both electrically and magnetically. Sa totoo lang, sa tingin ko dito, nagkabaliktaran itong dalawa dahil nga yung ng conventional transformer it is said na electrically insulated silang dalawa, yung primary and secondary. So that means na separated silang dalawa from each other. Kesa dun sa ng autotransformer na kung saan nasa iisang winding lang yung primary and secondary. Kung maano kayo ng clarification, pwede na lang atang gawin ay i-search na lang ito sa net para mas lalong mas clear or mas ma-clarify kung tama talaga yung difference. So, yun lang ang nasa isip ko. So in terms of connection naman, dahil nga ang ng autotransformer, again, the vital or the main reason kung bakit nagkakaroon ng difference is dun sa ng number of windings, which is only one. So nagkakaroon ng pagkakaiba daw yung ng connection depende dun sa pagkakatap dun sa autotransformer. Habang dito sa ng conventional transformer is pwede siyang i-connect directly dun sa load. Sa starting current, decreases lang ang ng autotransformer. Ibig sabihin yung current is less than the actual current. The starting current is less than the actual current. Habang doon naman sa ng conventional transformer, ang starting current daw decreases by 1/3 of the actual current. And because of this, so ibig sabihin, yung excitation current nung dalawa is small and large respectively. So next, dito naman sinasabi, which is more economical, the autotransformer or the conventional transformer in relation to sa cost, which is less costly kasi ang ng autotransformer, which means yung ng economical value or something is much more better kasi dun sa ng conventional transformer. Pagdating naman sa ng efficiency, autotransformer is more efficient kaysa naman sa conventional transformer. This is due to the reduction of the transformer material, which results to a much lesser ohmic loss and core loss. On to the next slide. So sa autotransformer, it has low leakage flux and resistance, resulting also to a lesser impedance compared to the conventional transformer. So the cost, na ulit lang siya. The losses, okay. So sa losses naman, the autotransformer has lesser losses compared to the conventional transformer, which is some of its advantage in terms of application. So dito naman sa ng output voltage, sabi daw ang autotransformer varies. The output voltage varies in comparison to the conventional transformer, which remains constant. Dito naman nagkakaroon na siya ng a huge disadvantage compared do sa ng conventional transformer. Gawa rin ata ito dun sa ng connection na kailangan niyang na depende sa tapping. Ay ang sabi dito, ang ng kapag maraming tapping, mas naman siya sa ng cost din. So disadvantage siya. So last is on the application. So sabi dito, ang autotransformer daw is used as a starter in an induction motor, as a voltage regulator in railways and in a laboratory. Habang doon naman sa ng conventional transformer, it is used in power systems, which helps it step up or step down the voltage. So yun po. Now that we are finished discussing about the differences between the autotransformer and the conventional transformer, please take note of the following formulas. So first is the power transformed, which is equal to the supply voltage minus the load voltage all over the supply voltage times the power output, where the power output is equivalent to the product of the load voltage, load current, and the power factor. Meron rin siyang another alternative formula na kung saan if the voltages are not given, you can use your yung transformation ratio. So the equivalent formula is equal to A minus 1 all over A times the output power, where A is the transformation ratios in relation to the autotransformer, which is already discussed by the previous reporter. So next is the equivalent resistance in terms of the primary. So RE is equal to the resistance from the winding AB plus the quantity A minus 1 squared times the resistance from winding BC. Next, yung reactance. Reactance in terms of the primary, which is equivalent to the reactance from the AB winding plus the quantity A minus 1 squared times the reactance from the BC winding. So, parang instead, nagkaroon lang siya nung sa ratio nung from sa ng AB winding and the BC winding, which is equivalent sa A minus 1. So, next, ratio of autotransformer to transformer. This is sa ng reactance. So, the reactance of autotransformer over the reactance of the ordinary transformer is equivalent to the square of the quantity A minus 1 all over A squared. Last is the factor for percentage basis. Ang example po niyan is yun sa ng voltage regulation, sa losses, and the percentage of the voltage drops, which is equal sa quantity A minus 1 all over A. Let's do some sample problem. So, ito po. 2,000 volts are to be stepped down to 1,200 volts. The load is 100 kVA at unity power factor. What is the power transformed? So, the first thing we need to do is to list the given values. The supply voltage is equivalent to 2,000 volts and the load voltage V2 is equal to 1,200 volts. Next is the VA rating, which is equivalent to 100 kVA or sabi na natin 100,000 VA, and at power factor at unity, which is equivalent to 1. So, the next step is to identify the values of the currents. So, ang kailangan nating currents is the I1, I2, and IBC. Where, ang ano mo dun sa I1 and I2 is to divide the VA rating by their respective voltage. So, sa I1, which ang gagawin na dito is equal sa 100,000 VA all over 2,000, which results to a value of 50 amperes. The next current, the I2, is equivalent naman sa 100,000 VA all over 1,200 V, which is simplified into 250 over 3 amperes, which is approximately 83.33 amperes. And yung dalawang values na yun, ang kailangan natin para makuha sa ng current for the BC winding, which is, gagawin mo is subtract the I1 from I2. So, I2 minus I1 is equals to 83.33 minus 50, which is approximately 33.33 amperes. So, next slide. I forgot to mention na yung ano pala nung sa IBC, it can be determined by using the KCL or the Kirchhoff's current law. So, dun kasi sa ano na yun, makikita yun sa diagram or sa figure ng auto transformer. So, parang it is what we learned in the previous years. So, hindi na kailangang i-elaborate pa. Okay, next. So, take note na ang pinapahanap sa atin is yung power transformed. So, yun nga, kailangan natin yung formula for the power transformed, which is equivalent dun sa quantity A minus 1 all over A times the power output. So, hindi ko na kailangan itong i-elaborate pa. Nasabi ko na to kanina. So, kailangan mo lang i-substitute yung mga values na nakuha natin from the previous slide, which is yung 50 ampere, the 250 over 3, 250 over 3 ang ginamit ko kasi mas exact siya kaysa doon sa yung approximate value, which is 83.33. Doon rin naman sa mga given values, ipa-plug mo na lang naman siya doon sa ng formula, which gives you a result of 40,000 VA or equivalent sa 40 kVA. So, yun. So, for this next slide, actually, is just an alternate solution for the sample problem na kung saan, dahil nga, given yung mga voltages from the problem itself, hindi mo na kailangan magparaan pa nung dun sa current na ginawa ko kanina. But, syempre, mas okay naman yung mas marami kang solution na ipapakita or mas marami yung mga understanding para dun sa ng application for auto transformer. So, ito. So, the next is yung formula for power transform na equal sa V1 minus V2 all over V1 times the power output. So, i-plug lang siya dyan. i-evaluate mo, yung 2,000 minus 1,200 all over 2,000 is simplified into 0.4, and yung power output na sinabi ko na product of the V2, I2, and the power factor na equivalent niya is 100,000. So, multiply na lang yung dalawa, which results to 40,000 VA or 40 kVA. So, yun lang po. This ends my discussion. Thank you for listening.